Hey, we got another cheap product review down in Akihabara today, and I found this. There was a tub of these at a shop called Sengoku, which is a general electronics parts and tool store, a very good store. If you're in Akihabara, check them out. And there was a tub of these, and they were being sold for 500 yen each, which was well within the impulse buy limit. So I picked one up. It's a Weller BP650MP. I've had a look at these on Amazon America, and they do sell them still. They're about 12 bucks, I think, 12 freedom bucks. But I got this for 500 yen, which comes to about 4.5 freedom bucks. That's also about 3.5 Brexits and 6.8 Aussie dollary dues. So not too expensive at all. Cheaper than you get it in America from Amazon, but it comes as a little bit of a kit. It looks like we've got a the soldering iron itself. It's battery powered, so we get 3 batteries included. Duracell's AA's there, and we've got looks like a bit of solder, a little metal kind of bracket, which might be a like a stand, and then a cap that goes on the top. It says we asked for it, so we're going to get it. Better heat performance, new switch with safety cap detent, auto shut off with safety cap attached. So when you put the cap on, it must push the switch to the off position. And battery cover orientation guides. I put a little mark on there so you put the battery cap the right way around. So they must have had an earlier version of this, and some people said, hey, it's a bit crap, make these changes, and then they've made the changes and we've got the new version. So it says it's 4.5 watts, maximum 480 degrees. So I've got my Hakko temperature sensor here, so we might rip this thing open, give it a bit of a test, and then see what's inside. I think there's not going to be much inside. Battery holder molded in, switch molded in, maybe connected directly to the end there. It almost looks like the tip is like an RCA sort of plug. I've seen that a few times on some other stuff. So let's cut this open, because it's in the molded plastic packaging that's really fun to tear apart. Alright. So I have a bit of metal, couple batteries, the cap goes on the top. Oh yeah, if we turn that on, yeah, when you put the cap on, it pushes the switch off, so that's the interlock function. Let's have a quick look at the instructions. And what is this? Ah, yeah, that tool isn't a stand, it's for taking the tip off. And yep, it's an RCA style connector. So that'll be positive and negative, I guess, and there'll be a little element inside the end here. So that little bit of metal is so you can, if it's hot, you can kind of flick it off. Somewhat like that. Shoot it across the room and melt whatever it hits. Looks like we've got an indicator LED there as well. And how do we open that up? Give it a squeeze. Oh, okay. I didn't squeeze it enough. That's a bit tight. And so, yeah, there's not much in there at all. I don't know if you can see down in there. It's pretty hollow. So the batteries go in that way. And then that one goes in that way. What's the date on these? Is there a date? March 2021 used by. So they're pretty fresh. Line up the little white marks. How does that go? Like that. There we go. And the red light comes on. Oh, yeah, that's getting warm. Bit of sample solder. Alright, so it works. It says it's got what's the it said somewhere the heat up time. Ah, right there, 30-second heat up. And it says on one set of batteries you can do up to 120 solder joints. Power on red LED indicator, long-lasting iron-plated conical shaped tip. So I'm not sure if you can get new tips. Maybe you can. It doesn't say here. Use alkaline batteries for best results. Yeah, of course. You're going to need that lower ESR. If you use those lithium batteries, it will be pretty alright too. But they're a lot more expensive, so it's probably not worth the added cost. Anyway. What's that say? Place a hot soldering iron standing upright so the tip does not... Oh, okay. Yeah, so stand like that when you finish using it so you don't melt everything. Anyway, let's fire this up. Let's see how hot it gets. So I'm going to use this solder. I'm assuming this is going to be some sort of flux core stuff. Being Weller, it might even be Weller brand stuff. So we'll turn that on. I'll just touch that on there to start with. Hopefully you can see that. 130, 150, 160, 190. 200 degrees, 215, 20, 230. Yeah, we're melting the solder. 250 degrees. That says 480 degrees C max. 320. 330. So that's definitely hot enough to solder. This thing might actually be useful. That was pretty quick. Looks like about 350 degrees. That's about what I've got my my soldering station set to, about 350, I think. Because I work fast, hot and fast. That way I can get in and out quick without the heat soak. If you have it on a lower temperature, you got to put the heat in for longer, and it can heat soak into the components. But because I work fast, I can get in and out quick, and I don't heat soak the components. So we're nearly at 400 degrees. That's all right. Okay, not too shabby. Well, I'm going to I want to open this thing up, but I don't want to do it while it's hot. Whoop. Alright. So, let's open this up and have a look. I wonder if we could convert this to a USB. That would be interesting. Put a USB plug in there, because it's 4.5 volts. I wonder if there's going to be some easy way to measure how much power... Yes, there it would be, because there's not going to be any electronics in here at all. That's why it kept going up and getting really hot, because there's no temperature control. So what I can do... Oh man, that's tight. What I can do is I can actually connect just the tip to my power supply, just for a minute, and then we can see how much power it draws. It's 4.5 watts, but it'll be interesting to see how much current is exactly being drawn. I think I'm using the wrong screwdriver. So the short one's in the front, and the two long ones will be in the back. Alright, let's see. Which way is that going to open up? Well, yep, that's all it is. It's all molded in. It's not much to it. Yeah, one battery sits here. Well, touches on that. Actually, I'll flip that over so it's easier to see how it works. Let's put that there. Okay, so basically you got your battery in here. When you switch it on, just here makes contact. Click, 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 click. Then we come around, we've got the LED there, which is in parallel with the element. And then being 4.5 volts, there's probably... Oh yeah, there's a little resistor in there. It'll be a not very high resistance, but enough there just to stop that LED from burning out. And then, yeah, straight through the element, back through the batteries, and then the cap has the connection there. So all the batteries are in series. because it's 1.5 volts per cell times 3, 4.5 volts. So that is all it is. This could be interesting, or useful at least, to do stuff on, like, you know, in your car or whatever, soldering up your new stereo. Okay, so that's cool. I'm going to just grab some cables and hook this thing up to my bench power supply and see what we get. I've got my clips. These are actually pretty cool. I found these in Akihabara as well, made by some Japanese company. And they've got a profile on the end, so you can actually clip them onto screws. So if you've got a terminal screw, it'll clip onto the end of the round head terminal screw. Pretty handy. So we're going to use those here. Resistive element, doesn't matter which way around it goes. I'll turn my meter to 4.5 volts exactly. And wind that current up. So we're pulling basically an amp at 4.5 volts. And that's hot. That's probably got even more hot. Quicker, sorry, not more, but quicker. Actually, let's plug that in here and let's have a look. 330, 340, 350, 360, 370, 380, 390, 400, 420. Yeah, it's going to go up a lot higher, up to 480. So it's going to go higher because we don't have the internal resistance of the batteries to deal with. Oh, it's starting to smell funny. I wonder if that's the element, or if that's the just because it's new. Anyway, that means we could run that off a USB with a like couple ohms resistor just to drop it down a bit from the 5 volts down to 4.5. But I can't really see. I've got to find somewhere to put this thing. I can't really see an easy way to fit a USB connector in there without sacrificing the batteries, because it's so built to a form, built to the exact size. Maybe I might play with it in another video. Anyway, I'm going to put this back together and we'll do a few test solder joints here and there. Maybe an SMD and a 3-hole. See how we go. If I can get this thing back together. Aha! Ta-da! Alright, I found a chunky circuit board here. This is from an old pachinko machine, actually. They're good for getting CPUs and stuff. But let's turn this thing on and see how long it takes to warm up. Red LED is lit. Oh, there we go. That wasn't too long, but that's only just the temperature. So I've desoldered this capacitor. You can believe me, it's a capacitor unless you've got X-ray vision. Might have to give it a little bit more time to warm up. I just sucked all the heat out of it into the circuit board. Could do with a bit of a tinning. Oof, the thermal recovery is pretty crap. Jeez, not going to solder too well on that. It's it's not quite up to the level of my Hakko station. That's not even molten now. Jeez. Okay, so in free air it seems alright, But as soon as you put it on something, it just falls over in a screaming heap. That's just terrible. I don't think I would bother with this thing anymore. I'm not impressed. 4.5 watts. Might be alright for SMD. I'll have to find some SMD. That's just abysmal. I'm not impressed. It's starting to piss me off. Holy shit. Nah, that's thumbs down. Thumbs down. Let's just try on a small pad somewhere. We're still on. We're hot. Okay. So on small pads, it's alright. What about this one? Yeah, see that's... Okay, that's sort of working. Let's go back to here and see what it says. Nope. Oh, nah. 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 Small stuff, yeah. SMD will be good. Well, by good I mean not complete rubbish. This has no SMD on it. Give me 1 sec, I'll see if I can find a board with some SMD stuff. Okay, so I found a SMD board. Brand new board from JLC PCB. I use them quite often. No affiliations or sponsorships. We'll give it the old Lewis Rosman treatment. More flux, more betterer. Give it a fighting chance. I've got a few just random resistors there. So, everyone has their own technique. I'm going to do mine. So we'll just give that a little bit of solder on one of the pads. If it will work. It's workable. It's workable. It does the job. It'll get you out of a pinch. As a comparison, let's do it with a real soldering iron. This is a FM2027, 70 watt, 24 volt. This is a Hakko. A good piece of kit. Well, that was much easier, besides having a bit of a funny angle, but that is a lot better. Alright, zoom right in, cleaned up the circuit board, and this is our result. So this one here is what done with the Weller, 4.5 watts of extreme power at 4.5 volts. That's 1 amp. This side here. And this side here is on my Hakko soldering station, 70 watts, 24 volts. Yeah, this one was so much more easy to do, even with the funny angles trying to get in there. But yeah, not even a contest when you're comparing a $5 soldering iron to a $1,200 soldering station. But yeah, you don't have to spend that much money to get a good soldering joint. You can see the difference. You might be able to see the difference there. It's a little bit messier. This one's nice and smooth because I just get the heat in easier. I'll get in and out quicker, so I didn't bake out the the flux or, you know, ruin the solder as much. But that is a functional solder joint, as slightly more ugly it looks than the other one. So I'll just zoom out. So this one here, how will I rate it? Ooh, sideways thumb. I'm going to give it a sideways thumb. I'm not going to give it a thumbs down because it does work under certain circumstances, and that's why I'm going to give it not a thumbs up, because at 4.5 watts, it's woefully underpowered. Yeah, it's all right for SMD stuff, and it's all right for thin wires and some like through hole if it's small pads. But if you're doing larger pads like on this switch or on the this is actually for a RCA jack, you're gonna have a bad time. You're gonna just be frustrated. It's not gonna work. So yeah, it's more of a toy than anything. I mean, if they made one with an 18650 in, that would kick out some real power. You could probably get, I don't know, 10, 15 watts or something easily. That would be a nice product. But it's going to cost a lot more too. So yeah, for $5, it does a job under certain circumstances. So I'll leave it up to you to decide if you want to buy one. But I would recommend you save a few more dollars, literally a few more dollars, and get like a $15 or $20 Hakko knockoff, one of those, the old style Hakko where it's like the black square box. I think I've got some earlier videos maybe on them, or maybe in my previous channel. But anyway, yeah, the Yihuas and the other brands there are. Or even if you really want to be a big spender, save up $100 or so and get an FX 888, the old Hakko FX 888 solder station, and you'll be so much happier than using one of these things. I'll probably chuck this in my box. I'll take the batteries out so they don't leak, but I'll chuck it in my toolbox, and maybe I'll use it if I'm in a pinch somewhere, but I think I'd rather lug my whole soldering station out to wherever I'm going with an extension cord than battle with something like this. Yeah, it won't be any good on the car. Thick wires and stuff. It's just, yeah, 4.5 watts. My first soldering iron. Anyway, I hope you you found that interesting and somewhat helpful. Give it a thumbs up. If you feel like it, hit that subscribe button, and we'll see you next time.